Hello everybody, welcome back. I am the Exam Mastery host, your virtual guide to cybersecurity and the CompTIA CySA Plus journey. Whether you are prepping for the certification or are just curious about defending the digital world, you are in the right place. Every week we break down complex security topics into simple, actionable insights to help you grow as a cybersecurity analyst. Let's build your skills, boost your confidence, and stay ahead of threats together. If you find value here, consider subscribing and sharing your thoughts in the comments. I'd love to hear from you. Hello everybody, welcome back. We are on vulnerability management maturity currently, because here it says I haven't done any of these, I haven't done any of those, right? So the next thing I want to do is get all of these done, right? So let's do vulnerability management maturity. Hello everybody, welcome back. Today we are going to be doing vulnerability management maturity for program evolution, right? We have what is vulnerability management maturity? Refers to the development and improvement of vulnerability management programs to effectively identify, prioritize, and remediate and monitor vulnerabilities. So we're going to go over the different maturity levels, right? One of the maturity levels is initial ad hoc, right? When I think of ad hoc, I think single one time, whatever's happening is going to only happen one time for ad hoc stuff, right? For this, we have reactive approach with no formal process, manual vulnerability scans and inconsistent remediation, limited documentation and no key performance indicators. An example of ad hoc would be a one-time command, right? A one-time bash command that runs in the shell, right? The Linux shell. So what it's doing is it's scanning the servers only after a breach is detected, right? We're using tools like Nessus and OpenVOS. OpenVOS is commercial, right? So it'd be better off that you use Nessus because it's free and open source, because you'd have to pay for OpenVOS. And then we have the challenges that would occur: inconsistent coverage, high risk of missed vulnerabilities, managed characteristics, basic process defined for scanning and patching, some automation tasks, assignment, limited metrics with total vulnerabilities. We have scheduled scans with Nessus and manual task assignment via Jira. So those tasks can range from like different vulnerabilities, I believe, right? But what is Jira? I've never heard of it, right? But it comes up throughout this course, right? As you can see in searching for indicators of it, right? But yeah, what it does is it creates a project that calls it SEC, and then it summarizes the task, which is to patch the vulnerability, right? And it just gives it that little description, right? Summary of what it's doing. Lack of prioritization, siloed teams is some of the challenges that you would get if you're using Nessus, Jira, or WSUS. So in defined characteristics, we have standardized processes, right? For scanning, prioritization, and remediation. Use of key performance indicators like mean time to remediate, mean time to remediate, which is also mean time to repair. But remediate and repair probably mean the same thing, right? Remediate means to fix it. Repair also means to fix it, right? Cross-team collaboration is established, right? So this is a little like automation thing, right? With YAML code up here and SPL code down here. Splunk query language code, right? Splunk code. And then YAML for Ansible. So we apply all the latest patches automatically, right? In Yum. So we're using the Yum all and latest, right? Become yes. So tools to automatically, automate the patching and stuff like that. The like updates and patching and upgrades and stuff like that. You would do that in stuff like Ansible or Splunk. And qualities for that automation stuff. The challenges with this is the scaling to complex environments, maintaining consistency with it. For quantitatively managed characteristics, right? We have data-driven program with advanced KPIs, key performance indicators. Integration with threat intelligence and risk-based prioritization. We have automated workflows for remediation. Example, correlate vulnerabilities with threat intelligence and Tenable. So what we would do in the shell is we would use the tenable-io command, if that's the right command, right? We would scan for the policy of critical assets, -- targets, prod servers. We'd also have SPL right here, so, this would also check for that threat data greater than 7.0. and Tenable.io, Splunk, and Threat Connect. Challenges: managing false positives, aligning with business goals. Optimized characteristics: continuous improvement with real-time monitoring, full integration with DevSecOps and compliance frameworks, proactive threat hunting, and purple team exercises. Example: real-time monitoring with Splunk and automated remediation via ServiceNow. We have our SPL code for Splunk, I believe, and we have our shell code for ServiceNow. Splunk, ServiceNow, and Kina security. Challenges that you would have: high resource investment, dynamic environments, and cloud. As an example, dynamic environments would be cloud, right? That's an example of a dynamic environment. Key steps to evolve a vulnerability management program. We have advanced maturity. Follow these steps along with CySA Plus. Establish a formal program. Define policies for scanning, prioritization, and remediation. Create a vulnerability management policy in Confluence. That's just an example of a program, a collaboration program, but you have tools like Slack and other things that can do the same thing, right? It's just a little text document that shows how you're going to create your vulnerability management policy, right? So it doesn't have to be Confluence. It could be Slack or any collaborative platform. Automate processes. Use tools like Ansible for patching and Qualys for scanning. We have patch critical servers with the APT package manager, right? You're updating all those packages and you're upgrading the distributions, right? And then down here, they're doing a Qualys CLI scan on a specific IP address and a specific subnet, right? We have threat intelligence. Correlate vulnerabilities to indicators of compromise from feeds like CySA threat feeds. And we have the Splunk line that would actually help you do that. For key performance indicators and metrics, how to implement them, you would run this Splunk command, which is vuln data, right? The index that you're pulling that data from, right? Status, what is the status of it? Remediation, right? Repaired, basically. Remediated basically means repair, right? Fixed, right? So we have the remediated status, right? The stats of the stats count that are remediated, right? Append, the search index vuln data, the stats count is total, and the eval rate. Remediated divided by total times 100, so that they can get that percentage, right? They're trying to get the percentage of remediated versus non-remediated, right? Foster cross-team collaboration. Use Jira or ServiceNow for task assignment and tracking. We have Jira, create, project, and we have the patch the server for the summary, and we assign it to the IT team, right? Continuously improve. We have MSF console -Q-X. Use exploit Windows SMB, and then we got the eternal blue, right? The eternal blue. So this is for the purple team exercise, right? Then we have set our host and then the IP address, and we run it on those IP addresses so that we can do purple team labs, right? Well, this is more of a tabletop exercise that they're running. So this is how you would run a purple team exercise, right? Tabletop exercise. For key tools for program evolution, we have Nessus and Qualys, right? Vulnerability scanning and reporting. So that will do a full scan on your targets. The targets could be yourself, so you can figure out where your vulnerabilities is. I mean, that's what a lot of people do, right? They run it on themselves, and that's why us as cyber analysts, right? We have to run Nmap on our own systems. With Splunk, we have key performance indicator tracking and real-time monitoring. So we're monitoring, right, the severity, the ones that are greater than 7, the CVSS scores that are greater than 7.0. We have Ansible automated remediation, which like hardens SSH for this example. We're making sure that the SSHD config, the SSHD config is secure, making sure that we have permit root login, right? And in that line, right, we're making sure that we're not permitting root login, and we're saying no to that. Then we notify that we're restarting the SSH. So this is what that automated remediation hardening would look like for stuff like that you have to harden. You don't want anybody getting root privileges from your SSH, right? You don't want anybody to be able to log in as root from SSH. because that would be very, very bad. Because say I just log in and then I automatically get root. That wouldn't be good. You have to do sudo to be able to get those privileges, right? So that's something that you'd have to do to harden it. For ServiceNow, Jira, task management, and collaboration, we have ServiceNow, we have the incident, and we have the CVE. For Threat Connect, we have the query, and then we have the type, and it's an IP value. So we have to say what type of value it is. So it's an IP value, and then we put the IP as the value. For best practices for CySA Plus, we have start with the baseline, document current processes and gaps, automate scanning and remediation, use qualities for scans and Ansible for fixes, prioritize based on risk, focus on critical vulnerabilities and assets. We have index vuln data, and then we have the CVS score is greater than 7 so that we can get those CVSS scores that are greater than 7 so we can prioritize those ones first. And then we have the asset criticality. If it's critical, we're going to be going and trying to get those ones first. For track key performance indicators, we have monitor, mean time to remediate or mean time to repair rate. We have remediation rate and false positives. We want to make sure that we're aligning with whatever compliance. For example, they're having to be compliant with NIST 853, PCI DSS, or HIPAA. We integrate feedback, use Purple Team exercises to refine the process. Challenges in program evolution. Resource constraints, limited budget or staff for automation. Complex environments, cloud and hybrid systems, complicate scanning, siloed teams, lack of collaboration between IT and security and DevOps, dynamic threats, evolving vulnerabilities require continuous updates, false positives, inaccurate scans can skew metrics. For practical example, evolving a program, we have access current state, identify ad hoc scanning with Nessus. Nessus CLI scan run. Then we have the targets within that subnet, right? 192.168.1.0. We define the process, created policy for weekly scans and 7-day remediations with service level agreements, right? We deploy the patches with Ansible. We update all the we update the Linux servers, right? The Yum packages, we're updating all of them to the latest, right? We're also tracking the KPIs. Like we did before. We're integrating them with threat intelligence, right? Verifying the hashes with this. We're querying the type. It's a hash value. With reports progress, we have a markdown document that is showing in the maturity of it. So the maturity level is defined. Key performance indicators. Remediation rate 85%. Mean time to remediate is 6 days. Next steps. Integrate DevSecOps and optimize for automation. In the CySA Plus, we have some tips. Understand maturity level. Initial to optimized. Know tools like Nessus, Splunk, and Ansible for program evolution. Explain how key performance indicators drive improvement and compliance. Practicing automating workflows and tracking metrics in the lab. Vulnerability management is very important, right? And if you learn these vulnerability management, program management techniques, you will be well prepared for the CySA Plus exam. And if you have any questions, comment down below in the comments. Any question that you have about the Security Plus. And thank you everybody for watching.